Welcome to this particular lecture of Unit 4. Today we will discuss about proximity sensor and IR sensor or infrared sensor. So what is a proximity sensor? Proximity sensors are sensors that detect the movement or presence of an object without making physical contact with the object and converts that information captured into the electrical signal. So when you are bringing the target object closer in close proximity to the sensor, then what will happen? Even without having a physical contact to the target, it will collect the information from the object and convert to a electrical signal. So these proximity sensors, they detect the presence of an object without even touching it. As these sensors are non-contact sensors, they do not cause any damage to the object obviously, and proximity sensors do not use any type of physical moving parts. So the proximity sensors, like how they sense the object in different ways. Based on that, it is classified into two types. One is a capacitive proximity sensor, another one is an inductive proximity sensor. So first, before we jump into the capacitive proximity sensor, let us understand this concept of parallel plate capacitor. Even I know everyone knows this concept, but still just recapitulate it. So in a parallel plate capacitor, we know the two plates of the capacitors, they are separated by the dielectric, and if these two plates of the capacitor, they are connected to a battery, this is the negative terminal of the battery. So from at both the plates we have holes and the electrons. Okay, so when we are connected across a battery, but since these are metal plates, obviously number of electrons will be more than the protons. So when we are connecting it across a battery, so the negative, from this negative end of the battery, electrons will be coming out and they will just start accumulating at this side of the plate. Okay, and what will happen to this side of the plate? The electrons that are there in this side of the plate, they will be getting attracted to this positive terminal of the battery. So after some time, at the right side of this capacitor, we will have the negatively charged arrangement, and the left side plate will be positively charged. Okay, so how the electric field, what will be the direction of the electric field from positive to the negative? Okay, so this is a very simple concept. Now when we discuss about the capacitive proximity sensor, it is classified into two types. One is a dielectric type, second one is a conductive type. So let us first see the dielectric type capacitive proximity sensor. In this case, this is the proximity sensor and this is my target or object. So in this case, the dielectric constant of the object should be higher than the air. Okay, so this is my dielectric type capacitive proximity sensor. Inside the sensor we have the two parallel plates. Okay, so these two parallel plates are isolated using the air as the dielectric. Okay, now when there is no target or no object, the capacitance of these arrangement will be very less. When this target moves closer to this sensor, what will happen? The distance between these two parallel plates will be reducing and the capacitance will increase. Now, these two parallel plates are connected to a oscillator circuit. Okay, so as the capacitance is increasing, what will happen? The oscillation amplitude of the oscillator circuit, this oscillator circuit, it basically generates a high frequency of electrical signal. So if the capacitance increases, then the oscillation amplitude will increase, or this will generate a high frequency oscillator signal. So as a result, what will happen? This oscillator circuit is again connected to a trigger circuit, and this trigger circuit, it is connected to the output arrangement. In the output arrangement, we have the transistor as the switch. Okay, so when the capacitance is high, the triggered circuit will process the signal that it is receiving from the oscillator, and the switch of the transistor will be on. Okay, and the sensor will be able to generate the output signal, and through which we can understand that the target has reached in closer proximity to this sensor. Okay, but in this case, this dielectric type capacitive proximity sensor can detect both metallic and non-metallic targets. Okay, now when the target, it moves away from the sensor, what will happen? The capacitance will reduce. As a result, I already told these two parallel plates are connected to the oscillator. So as a result, the oscillation amplitude will decrease, and when this amplitude and this signal will be detected by the triggered circuit. So when the triggered circuit understands that this oscillation amplitude has fallen below a threshold value, then the sensor will return to its initial state. So next type of capacitive proximity sensor is the conductive type. In this conductive type capacitive proximity sensor, we have the target as the target should be conductive. Okay, this is my capacitive type proximity sensor. So in this case, in this sensor, we have one plate which acts as one plate of the parallel plate capacitor, and this target acts as a second plate of the parallel plate capacitor, and in between this sensor and this target, we have the air acting as a dielectric. Okay, now this plate is one plate inside this capacitive proximity sensor. It is connected to the oscillator circuit. This oscillator circuit generates the electrostatic field. So when this target comes under the influence or close proximity to this electrostatic field, what will happen? The distance between these two parallel plates will decrease and the capacitance will increase, and this oscillator circuit, it will generate a high oscillation amplitude. Okay, so this is how it is connected. This in between this is one plate of the capacitive sensor, this is target is another plate, and the target is a conductive type. And what happens when this target comes closer to this sensor? This since this plate is connected to the oscillator, this oscillator circuit generates the electrostatic field, and this target comes under the influence of the electrostatic field. That separation between the two plates reduces, capacitance increases, and this oscillator, it will generate a high frequency electrical signal or a high oscillation amplitude. So when the triggered circuit receives the signal from that oscillator circuit, it will process the signal. It will detect any changes in the signal caused by an object coming near the sensor. So when the triggered circuit senses that there is an object, like I told, it is a conductive target, so it can be finger or metal. So this, in this output switching device, we have a transistor acting as a switch. Okay, so depending upon the signal that a triggered circuit is receiving, this switching device will switch on or off. Okay, like turning on a light or activating a machine like that, or turning off a light or deactivating a machine like that. The oscillator amplitude will reduce if the target, it moves away from the sensor. Okay, and switching the sensor back to its initial state. Next type of proximity sensor is inductive proximity sensor. In inductive proximity sensor, we mainly use the metal objects for detection. So let us look at the arrangement. We have a coil here at the top of this sensor, and this coil, when it receives the AC signal, it will generate the electromagnetic field. So there is a cup shaped core here which will hold this coil, and there is an oscillator circuit. What it will do, it will generate the radio frequency signal. Then the triggered circuit, it will process the signal that it is receiving from the oscillator circuit, and finally in the output we have the transistor acting as a switch. So depending upon the trigger output, triggered signal it receives, it will switch on or switch off the transistor. So let us see here. So this is my inductive type proximity sensor. Here we have the target or object. So this is, let's say this blue color portion is the coil. So when you are giving some AC supply to this coil, an electromagnetic field will be generated, and this field also will be alternating in nature. Okay. So as per the Faraday's law of electromagnetic induction, when these object or target comes in proximity of this electromagnetic field, an electric current called the eddy current is generated in this target. Okay, and as per Lenz, and this eddy current will create its own magnetic field, and as per Lenz's law, the magnetic field in this target will oppose the magnetic field of the coil which originally created it. Okay. Now what will happen when this object or target comes closer to this inductive proximity sensor, the eddy current of this target will increase and the electromagnetic field of the coil will reduce. The intensity of the magnetic field of the coil will reduce. Okay. Now, when the amplitude of this electromagnetic field of the coil it reduces below a predetermined level, the output state of this sensor it will switch from the normal condition. Okay, and it will generate an sensor output signal which will indicate that the target has reached in close proximity of the sensor. Okay. Now when the amplitude of this electromagnetic field when it increases, previous case was when the amplitude of the electromagnetic field it reduces below a predetermined value, the output state will switch from the normal condition. Next case, when the amplitude of this electromagnetic field will increase above a predetermined level, that means that will happen when the target is moving away from the sensor. Okay, in that case eddy current will reduce and the electromagnetic field of the coil will increase, and when it increases above a predetermined level, the output state of the sensor it will switch back to its normal condition. Alright, so this is all about your proximity sensor. Next sensor is the IR sensor or infrared sensor. So IR sensor, it is an electronic device. It emits the light in order to sense some object of the surroundings. It measures and detects the infrared radiation in its surrounding environment. So there are two types of IR sensor. One is the active IR sensor, another one is a passive IR sensor. Okay. In active IR sensor, it can both emit and detect the infrared radiation. So in active IR sensor, we have what? This is the transmitter. In the transmitter side, we have a light emitting diode or LED, and here we have the receiver. So when an object it comes closer to the sensor system, the LED it emits the light. It will obviously emit the infrared light. It falls on the object, then the light is reflected back from the object and it is detected by the receiver. Okay, so this active IR sensor it acts as a proximity sensor that we have just discussed, and they are commonly used in obstacle detection systems like robots. What is this passive infrared sensor? This passive infrared sensor here it cannot emit the infrared radiation. It is only able to detect the infrared radiation. So in the passive infrared sensor we have what? It has two stripes of pyroelectric material or a pyroelectric sensor. What is a pyroelectric material? It is a material that is able to generate the electric charge when there is a change in the temperature. Then it has infrared filter. Obviously, it will block out all other wavelengths of light. That means only the wavelength between 700 nanometer to 1 millimeter of lights will be passing through this filter. Rest of all the wavelengths will be blocked. A Fresnel lens which collects the light from many angles into a single point, and a housing unit to protect the sensor from other environmental variables like humidity.